Okay, so in this problem we are going to be talking about graphs of cubic functions. Okay, graphs of cubic functions. Now, what are cubic functions? Remember, equations are in many very different categories, many different types. We know that anytime you are plotting linear equations, okay, anytime you are handling linear equations, anytime we're simply plotting linear equations mostly come out as straight lines. Okay, so it can come out in that way. At times it can even come out in this way. When we are talking about quadratic functions, we know that quadratic functions can either come in an N-shaped way or in a U-shaped way. Okay, but when you are talking about cubic functions or cubic equations, they are more like two quadratic equations or two quadratic graphs just placed together. So anytime you're plotting them, they can come out either in this way or they can come out in that way. The highest power of x in linear equations is 1. The highest power of x, anytime you're dealing with quadratic equations, the highest power of x is always 2, the square. And the highest power of x, anytime you're talking about cubic functions, the highest power of x right there is always going to be 3. So this is how we can differentiate between linear, quadratic, and cubic functions. Linear equations have the highest power of x being equal to 1, and when plotted, they are just in the form of lines, hence the name linear. But anytime you're talking about quadratic equations, the highest power of x is 2, and they'll come out in the shape of a parabola. So this shape is referred to as the parabola. Okay, so it's going to come out in that way or in that way. Cubic functions, we've already seen that the highest power of x under cubic functions is 3, so it will either come in this way or it's going to come out in that way. Okay, in that way. So it's very much important that you have an idea. And notice cubic equations have 2 turning points, one maximum, the other one minimum here. This one minimum, the other one maximum there. Quadratic functions do not have, or rather, quadratic functions only have one turning point, either maximum or a minimum. Linear equations do not have any turning point because they are not curves. No, they aren't curves. So because they aren't curves, we're going to find out that they do not have any turning point, hence their graphs are continuously constant. But when you're talking about quadratic equations, cubic equations, these graphs are not constant. There is always a point at which they turn, and those points at which they turn, remember, are stationary points. We can also refer to them as turning points. So again, you just need to know this. Now let's try to handle our problem here. So feel free to pause the video and then you can just copy these questions that are here and then we can work out these problems together. So in this question, they are saying that the diagram below shows a sketch of the graph y is equal to x to the power 3 plus x squared minus 12x. Okay, minus 12x. This is a cubic function, this is a cubic equation. Notice the highest power of x right there is 3. And this is the graph that we have been given. So they are saying use the graph to solve the equations. Use the graph to solve the equations. The first rule, the first guideline that I can give for you is this one. And you can be writing this with me. Always compare. always compare the equation, the original equation. Always compare the original equation with the equations given to solve. With the equations given to solve. If you are not comparing, there will be challenges. Always compare the original equation that you've been given in the problem. Always compare it with the equations that you have been given to solve in this way. Notice that we have been given y is equal to x to the power 3 plus x squared minus 12x. Okay, that's our original equation. And then we have been given x to the power 3 plus x squared minus 12x is equal to 0. That's what we've been given. X to the power 3 plus x squared minus 12x is equal to 0. I can rewrite this or rearrange this one in this way. X to the power 3 plus x squared minus 12x is equal to 0, or rather is equal to y. Okay, this is the one that I'm rewriting. So if we compare these two expressions here, you're going to see that the only change that they made to the original equation was that wherever there is y, they had just substituted 0. Look at this. X to the power 3 plus x squared minus 12x is equal to 0. Here, x to the power 3 plus x squared minus 12x is equal to y. Your original equation, wherever there is y, they had just substituted what? 0. This brings me to two very important concepts that you need to understand anytime you are dealing with such problems. And these two concepts, you're not just only going to find them on graphs of quadratic functions or equations, even cubic functions, but you're going to also find them anytime you're talking about the coordinate geometry and the linear programming. You're still going to find these two concepts. What are they? Please don't forget that in the y-axis, x is always equal to 0. In the y-axis, x is equal to 0. This is concept 1. Concept 2, my friends, is this one. In the x-axis, y is always equal to 0. These are the two concepts. In the y-axis, x is always equal to 0. In the x-axis, y is equal to 0. Notice, when we rearranged our original equation to suit that equation that we had been given to solve, you're going to see that the y value here was just equal to 0. Which means that this thing is pointing where? Is pointing to the x-axis. So when you have been given such kind of a problem, okay, where the only change that they have made is that wherever there is y, they have just put 0, just try to see where your graph is meeting with the x-axis. Okay, I repeat the statement again. Wherever you just see that the only change that they have made is that on the y value or the y variable, 0 is the only number that has been substituted, just see where the graph is meeting with the x-axis. Look at our graph. Our graph is coming in this way. You're going to see that it's meeting the x-axis at -4, which is right here, on 0, and also on 3. These are the 3 points at which it is meeting with the x-axis. So what we are going to do then is that in order for us to answer this, We're just going to see where it's meeting with the x-axis, like we have said. So take note, it's meeting the x-axis firstly at -4. It's also meeting the x-axis at 0. It's also meeting the x-axis at +3. +3. X is equal to -4, x is equal to 0, x is equal to 3. That's it for this problem, the first one. So we only see where the equation has met, or where the graph has met with the x-axis, because in the x-axis y is always equal to 0, and that is just what we had made here. In the y-axis x is equal to 0, in the x-axis y is equal to 0. Very important concepts, these ones. So for the first one, where they said x to the power 3 plus x squared minus 12x is equal to 0, this is just what we do. What about this other one? X to the power 3 plus x squared minus 12x is equal to x plus 10. How can we handle this one? Well, again, the rule, compare your original equation, which is y is equal to x to the power 3 plus x squared minus 12x. What we have been given to solve is x to the power 3 plus x squared minus 12x is equal to x plus 10. Again, I can try to write this in this form, where I'll try to make these the subject of the formula. So if I rewrite this guy, so this one down here, this is going to be x to the power 3 plus x squared minus 12x is equal to y. Now, big difference here. When we had arranged, we saw that y was just equal to 0. And we said that it is only in the x-axis where y is equal to 0. But if you look at this one here, you're going to see that y is not being equal to 0 when we rearrange. You're going to see that y is going to be equal to everything here. Y is equal to x plus 10. So y will be equal to x plus 10. This is what we have seen. Y is equal to x plus 10. Just like that. Now, once we deduce that y is equal to x plus 10, what we now do is that we plot this thing on our graph. So how can we plot this? It's very essential that anytime you're plotting your lines, you only need two values or two coordinates. You first make a table of values where your x variable is here, your y variable is going to be there. Okay? Your x variable and your y variable are going to be there. Now, you don't need to put any extra boxes here. You only need 2 points in order for you to sketch your graph. So here we can pick any two values of x of our choice, provided that they are in this range that has been given. The range is starting from -5 to +5, so you can pick any value of x within this range and use it to determine the value of y. Don't try to pick any value that is outside this range. You will complicate things. So in this problem, let me just pick -1 and +1. I can pick them. So -1 and +1. Let us see how we can find the y values. Y is equal to x plus 10. y will be equal to, remember, on x we are putting -1 firstly, so -1 plus 10. So y will be equal to -1 plus 10, the answer is just going to be +9. So 9. Our x value is now 1, so y will be equal to x plus 10. So y will be equal to, on x we're just going to put 1 plus 10, and y will be equal to 1 plus 10, the value is just going to be 11. So y is equal to 9, y is equal to 11. So your other y value is going to be 11. So your coordinates are going to be -1, 9, and 1, 11. -1, 9 and 1, 11. You only need two values or two coordinates for you to plot your line. You don't necessarily need to reach your line to that end. So we are having -1, 9. So -1, 9. So here we're just going to approximate. Okay, so if this is your -1, perhaps your 9 can be somewhere here. Okay, and then the other one is 1, 11. So 1, and then your 11 point can be maybe, say, somewhere here. Okay, remember, you're just approximating. Okay, and then once you do that, what you're just going to do now is that you're just going to join these two lines or 2 points. So how are we going to join them? Well, it's very easy. This is just going to be like this. Okay, it's just going to be like this. Let me try to do this. Make sure that they are meeting with your graph, at least in that way. You make it like that, and it's essential that you always label your graphs anytime you plot them. So this was y is equal to x plus 10. You label it. Okay, y is equal to x plus 10. And then once we do that, just see now where that line is meeting with your graph. So they are meeting at this point here and also there. So what we can then do is that you can project the line down like that. And here. And here. See where they are falling in the x-axis. So our answers here are going to be x is equal to After comparing here, we noticed that our y was just equal to x plus 10. We didn't just end here, we had to plot this. After plotting this, we made this. We drew this line, we plotted it, and then we saw where the line was meeting with the graph. We saw the x values at their points of intersection, and those same values of x at which they are meeting at, those are going to be our final solutions for this problem. Hence, x is negative 3.88, x is equal to negative 0.6, and we're also seeing that x is also going to be positive 3.5. Okay, so I hope this is making sense for you. The third one, calculate an estimate of the A, gradient of the curve at the point where x is equal to 3, negative 3. Gradient of the curve at the point where x is equal to negative 3. There are two methods in which you can determine your gradient. Here, there are two methods. The first one that I'm going to show you is the calculus method. The calculus method. Now, when you're using the calculus method here, don't even be alarmed. Y is x to the power 3. Okay, y is equal to x to the power 3 plus x squared minus 12x. Now, when you're using divided is what they call differentiation. Black pen. Differentiation. And there is just what they call integration. So we use differentiation here rather than integration. But again, of course, there'll be a time where I'll just come and explain the calculus in much more depth. But take this as an introduction, slight one. So when you are differentiating, so we use differentiation rather than integration. So when you are differentiating here, how this one is going to be, on your y, you are going to put dy dx. Dy dx here means differentiate y with respect to x. So dy dx, differentiate y with respect to x. So the basic rule is that we always multiply our power with a coefficient. Notice, even though they haven't shown it here, there is a 1. So this is going to be like 3 times 1, which is just going to give us 3 x. And then what we do is that we always reduce our power by 1. 3 times 1, 3. 3 minus 1. Plus, same thing here, there is a 1 here even though they haven't shown. So 2 times 1, the answer is going to be 2 x, and then this is 2 minus 1. Minus, there is a 1 here, 1 times 12, that's just going to be 12. X to the power 1 minus 1. So this is going to be 3x squared plus 2x minus 12 just. Because if we look at this expression, this is x to the power 1 minus 1. 1 minus 1, the answer is just going to be 0. And any number or letter that is raised to the power 0, the answer is always 1. Okay? Any number raised to the power 0, any letter raised to the power 0, the value is always 1 as our final answer. Okay? The the value is always 1 as our final answer. So once you differentiate, this is just going to be like dy dx will be equal to 3x squared plus 2x minus 12. Now, once we make it in this way, what is going to happen is that we are going to start substituting the value of x that we have been given. The value of x that has been given, remember, they have set at the point where x is equal to -3. So in this expression that we have made, what we're now going to do is that wherever there is x, we're going to substitute -3. So this is going to be 3, -3 squared plus 2, -3 minus 12. So 3, 9 minus 6 minus 12. So this is going to be 27. 3 times 9 is 27. So 27 minus 6 minus 12. Our gradient here is just going to be 9. dy dx represents the gradient. After you differentiate, the x value that you have been given, substitute it, and the final answer that you're going to have will be your gradient. For the sake of practice, let me just put another example so that you understand the whole concept here. What if we had been given this? 4x to the power 3 minus 2x squared minus 3x. And then we're being asked to differentiate. For the sake of practice, y would change to dy dx, differentiate y with respect to x. Remember, power times coefficient, 3 times 4, 12, x, 3 minus 1, minus 2. Let me say that again. The power here is 2. The coefficient here is 2. 2 times 2, 4. So let me just write 4. X, 2 minus 1. Of course, this is going to be minus 3. X, 1 minus 1. So at the end of the day, we're just going to have 12x squared minus 4x minus 3. So take note, if you differentiate a quadratic equation, or if you differentiate a cubic equation, you form a quadratic equation. So this is how you can change a quadratic equation into, or rather, this is how you can change a cubic equation into a quadratic equation, by differentiating it. When you differentiate, the highest power of x decreases. When you're integrating, the highest power of x increases. Okay, but again, that's going to be another topic in itself. But for now, just know that anytime you differentiate a cubic equation, you always form a quadratic equation. This is also true when you say that when you differentiate a quadratic equation, what you're going to have is a linear equation. And of course, if we had been given any value of x here, what we would have done is that we would have just gotten that value and we would have substituted it here, and that would have been our final answer, of course, if we had evaluated and worked it out. But so far, this is just how it's going to be. You differentiate. After you differentiate, you just substitute the same x value that you have been given, and then that's going to be it. Alright? So in this problem, I'm just going to use the calculus method. In the other video, in the other problem, I'm going to use the tangent method. So there are two methods. There is the calculus method. The other one is the tangent method. the tangent method. So you see me determine that in the next video. So this is how the calculus method goes. Okay, this is how the calculus method goes. I hope you get it. Now, lastly but not the least, so we have calculated an estimate of the gradient of the cave at the point where x is equal to -3. That has been done. And then the other question, the final one that we've been given here, is to determine the area bounded by the cave. X is equal to -3, x is equal to -1, and y is equal to -10. Okay, so the other problem that we've been given here is to determine the area bounded by the cave. X is equal to -3, x is equal to -1, and y is equal to -10. Let us work this out very carefully. They've said the area bounded by the cave, x is equal to -3. So I can encourage you to do this. X is equal to -3 is like this. Okay. X is equal to -1. X is equal to -1. So okay. And then y is equal to -10. Y is equal to -10. Now our y is equal to -10 is down here. So let me extend the lines like this. Just like that. And then y is equal to -10, we plot it in this way. We make a line that is passing through the y-axis, specifically -10. I want you to see exactly what we are making here. Let me try to do this. They said x is equal to -3. They said x is equal to -1. And then y is equal to -10. And then they also said the cave, area bounded by the cave. So this is the cave right here. You should first make the shape. Try to locate the area which they are talking about before determining its value. I don't know if you have seen the shape that has been made. X is equal to -3, x is equal to -1, y is equal to -10, and of course in the first place they said the cave. So this is the shape that has been made. Now when you are determining the area, what we normally do here is to understand this point. The area of the shape given can be solved like this. Look at this. There are some minor shapes that you can introduce here. Some minor shapes. So if we look at it very, very carefully here, I can make a trapezium. It's coming like that. There will be a mini one that I can also put here. Remember, it's an estimate. There is another that is going to come in this way. Okay, there is another that is going to come in this way. So there are two shapes that I've made here, trapezium shapes, which brings me back to this. When you're talking about a trapezium, a trapezium will either be given in this way. That's a poor drawing, but just have an idea. it can either be brought in this way, or it can even be in this way. Any of the two is a trapezium. Haven't you seen this? Even here, if I just like try to bend it over a little bit, notice that you're going to have this trapezium. Even for this guy, if you try to look it up in that other way, you're still going to have a trapezium. Now, anytime you're determining the area of a trapezium, the area formula of a trapezium is always given by A is equal to half A plus BH. Under physics, we are going to teach you to say that the area under the cave represents the distance, especially when you have been given a velocity time graph. The area under the cave or under the graph always represents the distance. Okay, always represents the distance. So A is equal to half A plus BH. Now, just a quick revision. If this is a trapezium, A is always this level. That is the difference between these 2 points. B is always here between these 2 points. And of course your height is just like that. Okay? Your height is just like that. So even if it has been given in this way, this is always your A, this is always your B, and this is always your H. So don't forget this. So if we look at it now very, very carefully, you can see that they are symmetrical. If we sketch, they're symmetrical. So to just cut the long story short, what I'm going to do is that I'm just going to find the area for 1, and then I'm now just going to multiply that value by 2. Okay, because they're looking very, very symmetrical. Okay, but if they are not symmetrical, then you should find for this one and also find for the other, and then you just add the values together. Probably maybe in the next video I'll show you that. So how this one is going to be now is like this. Remember, if we look it up in this way, according to how I had shown you, you're going to see that we are focusing on this. So our top part, like I had shown you, that's going to be our A. And then our B is going to be this part. Our H, our height, is going to be that way. Okay? So let us see how we can determine our A value. Our A is starting, so let this be reflected in the y-axis. So assume all values to be positive in this problem. Assume them to be positive, because area doesn't come out negative. No. So you're going to see that this one is starting from like -10. Okay, -10. And then we are seeing that it's going to reach on somewhere like if this is 10, 15 can be here. Perhaps maybe we can say that this is 16. Okay, this is 16 by just brief approximation. This can be like 16. So it's starting from the -10 to 16. So in order to find the difference, this is going to be 16 minus negative 10. Let me write it properly here. Our A, remember, you're starting from negative 10 and then you're going all the way to 16. So this is just going to be like 16 minus the negative 10, and A will be equal to 16 plus 10, which is, I believe, just going to be 26 units. U is starting from the same negative 10 and then it's going all the way. If this is 20, just look at this. This can be maybe say 22. All right, 22. So starting from the negative 10 to 22. So your B is going to be 22 minus negative 10. So B will be equal to 22 plus 10, which is just going to be what? 32. In that way. So B will be equal to 32 units. So look at where your A is starting and ending. A was starting on 16, or rather negative 10, ending on 16. So 16 minus negative 10. Your B was starting from the same negative 10 to 21 or 22 as we had approximated. So that's going to be 22 minus the negative 10 that is there. Okay, 22 minus the negative 10 that is there, and this is just going to be 22 plus 10, and that is going to be equal to 32. So our B value is going to be 32 units. Not centimeters, not kilometers, just units. And then your height is going to be reflected in this way. Notice that it is starting from negative 3 to negative 2. Negative 3 to where? To negative 2. Just look at it. Negative 3 to negative 2. So when finding your height is just going to be negative 2 minus negative 3. That's how it's going to be. Negative 2 minus negative 3, and negative 2, negative times negative, positive, so negative 2 plus 3, and negative 2 plus 3 is just going to be a positive 1. 1 unit, just like that. Negative 2 minus negative 3, negative 2 plus 3, which is just going to give us 1 unit. Once you do that, okay, once you do that, you can now just go into that original formula that we've been given, where we are going to have A is equal to half and then A plus BH. So A will be equal to half. Your A is 26. Let me write that better. Plus your B is 32. Your height is just times 1, which won't even make much difference. So A will be equal to half, okay, half times 26 plus 32 by 1, and your value is just going to be 29. You see, the way you're punching these things on your calculators is very, very much important. I will try to demonstrate one day just how the calculator can be misleading if you're not using it correctly, because at times we might even be given a calculator to solve some questions, but we're getting them wrong. So your A is going to be equal to 29 units squared. Okay, not centimeters, not kilometers, but it's just going to be 29 units squared. Now listen, this is only for this shape. Someone right there can get done and then be like, I'm done. No, you're not done. This was only for this shape. That's why you need to be fast. Now, having seen that these are almost symmetrical, or just symmetrical, we can say, okay, just symmetrical, what we can do is that we can just multiply our value by 2, because it shows that the area for this guy and the area of this guy are equal. So rather than repeating the whole procedure, the whole process again, your final answer is going to be like area shaded, not area shaded, area bound. We normally use area shaded when we're talking about the addition mathematics mostly. This is where problems like that are found. So the area bounded will just be equal to 2 times the same 29 units squared that you had found there. And 2 times 29, I believe for once, is just going to be 58 units squared. Once you do that, then you have determined your area. So be very careful. Trapezium shapes can be created. And not forgetting the trapezium shapes are always given by the formula, that is the area, half A plus BH. So once we determine that, then I guess that's it for this problem. That's how we can use our graph to solve those equations. We use the calculus method. Of course, there are 2 methods, the calculus method and the tangent method. In this video, I've just shown the calculus method. I'm going to show you the tangent method in the next one. Okay, so once that happens, then that's it. That's it for this problem. So practice. The more you practice, the more you become better. It really helps. So thank you very much for watching.